Then we have a term in microcontroller called addressing range. Every microcontroller has an address range. The address range that we are talking about here is its program memory, right? It used to vary microcontroller to microcontroller, right? Number of address line that we have in a particular microcontroller for program memory, that much of bytes can be its program memory. So if it is an 8K program memory mean, according to that much of address line should be there, right? That is very important. The number of address a microcontroller can access varies from process to processor, I think controller to controller, but the underlying hardware is similar. So the address range is this one. It is purely based on the number of address lines that you have, program memory address line that you have in your microcontroller. So other memory types that we discussed now, we discussed generally about ROM. I told that EEPROM, flash memory. EEPROM means to erase the existing content in that particular read-only memory. They use an UV light. Every chip used to have a window to send the UV light. By keeping the UV light for certain period of time, you can erase the content of that ROM. This is called as EEPROM. Another type of PROM is EEPROM. Here it is erased using high voltage. Using voltage pumps, they are erasing it and you can program them. Right, reprogram them. This has an option to erase the content selectively. If you want to delete only some 10 letters, you can selectively delete those 10. But EEPROM, you cannot do like that. You have to delete entire content. Right. The flash is combination of advantages that we have in EEPROM as well as EEPROM. Right. Here also to erase high voltage signals only used so that we don't require any sort of UV light, those sort of things. Right. But EEPROM, you can selectively erase, no. So in flash, you have to erase the entire thing. That's how it is. Unlike EEPROM, you cannot selectively erase portion of the memory. In case of flash, you have to erase the entire thing and have to reprogram it again. So that is the limitation that we have in flash. The microcontroller that we are going to use for in this course, no, which is having flash as program memory right now. So it is not having EEPROM. So according to that, we will have our flashing routine to support the data flashing in a flash memory. So that is the thing that we have to do, that we have to consider. Then the term interrupts. What is interrupts? A signal sent to a microcontroller which causes it to stop its current execution and perform another action. Interrupts allows microcontroller to interact with this environment. Without interrupt, polling is the only solution. Can be edge triggered or level triggered. So by the term interrupt, we come to know that it is a distraction. Why we have to distract? Why don't the microcontroller run its job like one after another? Why it has to do stop certain thing and how to do something else? Right. That is a need of real time. Let us say I want to send a control signal from a PC to a microcontroller called. By receiving that command, it should activate some door or some control some devices or actuators, something like that, let us say. Right. So the microcontroller doesn't know when that control signal will come. Yes or no? What it will do? It will do moment I power the microcontroller, it will run the basic routines and then it will wait in an infinite loop. It should wait. Why? When it receives a control signal from the computer, only then it can do any task. Right? That's why it is waiting in infinite loop. So it is already engaged in a job which is never ending. If I want to, moment the PC want to send the command, it should stop. I think it should do the job. It should accept that command and how to execute that command. So if that is the case, it should leave its current activity and have to go and execute some other programming routine. Right. That is to achieve that only they brought this concept of interrupts. What will happen now using when the microcontroller is supporting interrupts means there is a import called serial port interrupt. Right. Serial port receive interrupt. Right. You can enable that in a microcontroller. When you are waiting in that infinite loop, moment you receive a character from the PC, moment you receive a character from the PC to the receive register of microcontroller, it will generate an interrupt. It will generate a distraction. What it will do in the program counter, they will load a address. They will load a address, program memory address. What that address? In some microcontroller, they have list of address. One address for one interrupt. Let us say serial port interrupt, they have assigned the address, program memory address 5. Moment valid character, if the valid character is received from the laptop or PC to the receive register of microcontroller, the program counter will be loaded with the program memory address 5. It will jump there. Whatever maybe your infinite loop may be in the memory address 1000, no problem. So program counter value is 1000, it is infinitely waiting there. The moment it got the interrupt, the program counter is loaded with 5. They will go to the memory location 5. If you have some function address there, they will execute that function. They will go there and will execute that function. Once the function is completed, they will come back to the original memory address where they were executing. That means the infinite loop that they are executing, that memory address will be loaded back to program counter. Program counter. You can ask me a question. See, initially the program counter values was 1000. In that time, they were waiting in an infinite loop. We got the interrupt. Because of that, program counter value is changed to 5. Now that
Are you engineering graduate who want to kickstart your profession in automotive domain? Are automotive professional who want to switch your job to interesting positions with higher packages? Are you professional who look to work for great automotive OEM? Are you software professional who look for automotive job in Germany, France, UK, and US? Not sure about where to start? Then contact Yahasia Software for more details. They have nearly 20 years experience in corporate training and helped many professionals to achieve their dream job in automotive domain. They have students across 67 countries. They are conducting regular training on various topics. Automotive system testing using Python and embedded C for automotive are trending courses from them. Hence, to make your dream true, contact them now using 875-451-8745.
we lost the memory address 1000, after completing the interrupt service routine, how does the program counter know about the old address? Do you understand my question? See, when it was running an infinite loop, the address in which it is running is the program counter value is 1000, because in memory location 1000 we have infinite loop. It is running that. Moment we got a valid character from the computer to the receive register of microcontroller, it generate the interrupt. That interrupt load the memory address 5, program memory address 5 to the program counter. Now the 1000 is lost. Now we didn't store 1000 nowhere. Right. Okay, we went to interrupt service routine. We service the interrupt service routine. The job is done. Now we have to come back to this original infinite loop. how it is handled in microcontroller, how it is handled in embedded C. Any idea? Based on your previous experience?
I
Come on.
think it is based on ISR.
Correct. Interrupt service routine is again another program memory location. So let us say they have a memory location 2000. They have routine for interrupt service routine there. That is a program for interrupt service routine. Let me explain them via some diagram so that you will have an idea. See here, I have a, this is my program, my embedded program. Let's say move A comma B, and then I have a label here. I call that label as wait and branch conditionally to wait. These are just like a mnemonics. So after executing the program, see, this is the beginning of my program address. Let us say it is 1000, right? Address 1000. Maybe this wait is in 1001. Let us consider like that. So program counter is having the value 1001 when it is waiting in infinite loop. The branch conditionally mean it will simply wait here. So at that time from the PC, there is a register in a microcontroller. You can connect the PC line, the signal serial port line to that microcontroller. Whenever a signal comes there, it will digitize. Let us say I that receive register, RC register is contain a content A, capital A. It is received capital A, which is successful reception. Once that happens, it will, what they will do is you can configure a serial port receive interrupt that will load program counter value to 005. So at the memory location 5, right, in program memory, I will have like branch to ISR. In ISR, I have something like send it to otherwise display A, right? And then I will say RET, that means return with interrupt enable. Return. RETA, I believe. Yes. Return with interrupts. Right. Okay. They completed. The moment we got interrupt, program counter value become 5 from 1001. We come here in when we come to 5, they said ISR. ISR may be in different memory location. 4000 something like that. Moment we received branch to 4000, program counter will loaded with 4000. In 4000 we have this instruction, it is executing. After completing execution, now it has to return back to this 1001, but we have not stored the 1001 anywhere. If it happens like that, what will do means the microcontroller doesn't know where to go. It will malfunction. That's why we are using these stack memory that we have now, that we allocated a part of RAM, right? Before they branch to, before the serial port interrupt store 5 to program counter, they will push the current program counter value to stack memory. This will be in the top of the stack. The 1001 will be top of the tags. Now we have 1001 in the top of the tag, right? After that, we got program counter value to 5. When we go to 5, we got memory location 4000. There we have a interrupt service routine. We are executing it. After executing it, what happens? We have to return back to 1001. At that moment, this instruction will pop the top of the stack to program counter. so that your program counter will have the value 1001 again. Again it will come and will wait until it receives another character. Do you understand now how the stack is used? What is interrupt service routine? For every microcontroller, they used to have list of they used to call that interrupt service vector table. This is more popular in microprocessor. In microcontrollers, some of them have multiple interrupt vector. That means multiple addresses for interrupt service routine. So each address will be allotted for one interrupt. Serial port receive interrupt address 5. Then timer interrupt address 4. The moment they come to address 4, which means that timer interrupt happened. If they come to address 5, that means the serial port receive interrupt happened. Like that, they will make the decisions. In some microcontroller, they will have only one address. The controller that we are going to use now in this application, which is having only 0x4. So whenever any interrupt happens, whether it is a timer interrupt, receive interrupt, A to D, unlock to digital conversion interrupt, whatever it is, when there is a interrupt, they will come to address 004 will be loaded with program counter. When we come to program counter, now we have to validate different conditions. They will set the flags, whether the interrupt is based on serial port receive or transmit, something like that. Right now, based on that flag, we have to execute different routine. Is that clear to you or not? The one is some set of microcontroller as an interrupt vector table. For each interrupts, they have dedicated program memory address. Whatever instruction you have in that particular address will be executed when that particular interrupt happens. That is very straightforward and easy. When in some microcontroller, for any interrupt that happens, they will come to a single memory address only. Right now, from in this memory address, you have to branch to a routine that should validate whether the interrupt service routine interrupt happened because of timer expiration or serial port receive or some other means. Based on that, it will execute different piece of code. So this is another method. This one is little bit slower than what I explained before. So there is a difference between these two. Is that clear to you now how these interrupt service and interrupts are working?